Okay, for 2D simplification, there's only really a couple of things to be careful of. When you're doing the study design, um, one thing I recommend you do is after you pick the front plane, and we'll go axisymmetric, and then select the axes from the tree. When you start out, you'll see it's on the left hand side, it's showing the section. Leave it that way. What you'll find is after you select that, and then if you do a Control 2 to change the view to the back view, the reason I like leaving it this way is that when you show the solid revolves around relative to that section. It doesn't cover it up by revolving it out of the screen. So that's the reason I do the back view instead of the front view, to look at the model on this side. Everything else here is pretty straightforward. It's using a default global bonded contact, so that locks in the bottoms of the seals into each component, and that's why we just add the no penetration between the top edges of the seals and the appropriate face. So that's why we do that. Other than that, this model's pretty straightforward. Again, the parametrics is something that's key, and we might see if we can come up with an additional demo to showcase changes. I was literally using the latch to try that. It's just sometimes with nonlinear, the mesh sensitivity makes it a little tricky to get that to work. But with this one, if we look at the slice, it's on the front plane. There's not much else really for this model. The one nice thing, you'll see I've got a contact set up for penetration between those two bodies. That's all that's there, so that's all that's needed. And all we're doing is we're enforcing a 5mm displacement to put this over onto the clip. Initially you had this starting outside of contact, but what would happen is this would initially penetrate, so it's sort of like it collides and you get peaks in the stresses, which I'm not really concerned about the stresses here. I was more concerned about the stresses out here. So that's why we're starting in contact and we're just pushing it over the clip. Again, the thickness is important. So when we're specifying the thickness for the plane of stress, we're using the thickness which is 1.625mm for the actual latch itself. That's where that number comes from, so it accurately calculates the stresses for you. That's really all there is to these models. Like I said, the solve time's pretty quick. Even with the other model for the seal system, you could actually put a mesh control in there just on the seals using the per part size. If you want to get a really fancy looking mesh and maybe have that one pre-saved, but create a second study to showcase the initial start if you want to as well. So pretty easy.